Welcome. In this lesson, you're going to solve several questions on approximation and errors. Let's go straight to the questions. Question number 1. Find the percentage error in the total length of 4 rods measuring 12.5, 24.5, 12.9, and 10.1 centimeters, all to the nearest 0.1 centimeter. So we're going to start by getting the formula for finding the percentage error is obtained by the absolute error over the actual. In this case, we're looking at the total length of the 4 rods, so it will be actual length multiplied by 100. So that's the first thing. The next thing we're going to do is to obtain the limits within which all these measurements lie. And since we know the least unit of measurement is 0.1, so the absolute error for each of these measurements will be obtained by, so the error in each measurement will be obtained by a half multiplied by the least unit of measurement, which is 0.1. We get this one as 0.05. Therefore, what you're going to do to obtain the limit within which all these measurements lie, we're going to add these will be addition or subtraction of 0.05 to each of these measurements. Let's get started by getting something that we need in this question. We need 3 important things to solve these. We need, number 1, maximum length. Then we also need minimum length, and lastly we need the actual length. So those are the 3 things that we need. So let's begin with the maximum length of all these rods. So to obtain maximum length, we shall take each of these measurements and we add this error 0.05, and this is what we shall get. So when we add all these, we get 12.55. Remember, the first one is 12.5, so this will be 12.55 plus 24.55 plus 12.95 plus 10.15. So we obtain that by taking each of the measurements that we have here and we add plus 0.05. So when you take the total length of all these, this is what you get. When you add everything, you get this will give 60.20. The second thing that we require is the minimum length, and to obtain the minimum length we shall subtract this error 0.05. So in each of the measurements we subtract, and this is what we get. 12.45 first one plus 24.45 plus 12.85 plus 10.05. So that is after we subtract my 0.05 from each of the measurements. When you add this is in calculator, this is what you're supposed to get. You get 59.80. The last thing that we require is the actual length, and the actual length we're not going to add 0.05 or subtract. So the raw figures, the way they are, these are the raw figures, so the way they are. So this is 12.5 plus 24.5 plus 12.9, then plus 10.1. So those are the figures, just for confirmation. So when you get the sum of all these, this is what you get. You get 60.0. Now, having these three, we can now be able to obtain the percentage error. So what we need to get is the absolute error in addition of all these lengths, and this one will be obtained by getting half of the maximum length minus the minimum length. That is how we get the absolute error in finding the total length of the rods. So this will be given by half the maximum length. We have obtained the maximum length, it is there, 60.20, minus the minimum, which is 59.80. So this gives half. When you subtract 60.20 minus this is 59.8, you get 0.4. Working out this will give 0.2. So that is the absolute error. We can now obtain the percentage error. Since we have everything that we needed, percentage error is given by absolute error, which is 0.2, over the actual length, that is the total length, which is 60, multiplied by 100. And this gives, when you work out this using the calculator, this will give 0.3%. So that is how you're supposed to work out that question. Question number 2. The top of a table is a regular pentagon. Each side of the pentagon measures 40.0 centimeter. Find the maximum percentage error in calculating the perimeter of the top of the table. So in solving this question, there are 3 things that we require to get, actually 4 things that we require to get. And number 1, we need to get the actual perimeter. We also need to get the maximum perimeter. And lastly, we need to get the minimum. So let's start with these, because we also need to get, apart from these 3, we also need to know that to obtain the percentage error, as we have said in the previous question, this will be given by absolute error over there. In this question, we are dealing with the perimeter, so it will be the actual perimeter. We multiply this one by 100. So that is very important to note. Is everything multiplied by 100. So let's begin with the least unit of measurement in this question. This is a pentagon. A pentagon has 5 sides, and one side is 40.0. So therefore, the least unit of measurement is 0.1, and therefore the error in each of these measurements, which would be used to obtain the maximum and the minimum, will be obtained by half 0.1, which gives 0.05, and therefore the length of this pentagon will lie between, that is 40 0.0 plus or minus 0.05. So those are the limits. So to obtain, let's go to the actual perimeter. The actual perimeter will be obtained by, there are 5 sides. So the actual one is 40.0. There are 5 sides. So that is the actual perimeter, which will be 200. Then the maximum perimeter. The maximum perimeter will be obtained by taking 40.0. Then we add 0.05. So this will be 40.05 multiplied by 5, and this will give 200.25. 200.25. Then we go to the minimum perimeter. This one will be obtained by taking 40, subtract 0.05. This gives 39.95. We multiply by 5, and this gives 199.75. So after obtaining the actual perimeter, maximum perimeter, and the minimum, now let's go to now getting the absolute error in finding the perimeter. So absolute error in finding the perimeter is given by a half. You get the maximum perimeter minus minimum perimeter, all of which we have obtained. So these ones will be a half. The maximum perimeter, we've obtained maximum perimeter is 200.25. Minimum is 199.75. It's 0.75. Yeah, 0.75. So this gives, when you work out these, you get half. The whole of these will give 0.25. So this is the absolute error. Now to obtain percentage error in the perimeter, the maximum percentage error in the perimeter will be given by absolute error, which you have obtained as 0.25, divided by the actual perimeter. The actual perimeter is 200. Everything multiplied by 100. So this one, work it out using the calculator. This one gives 0.125%. That is how you're supposed to solve that question. Question number 3. The base and the perpendicular height of a triangle are measured as 8.2 centimeters and 6.3 centimeters respectively. Calculate the percentage error in calculating the area of the triangle correct to 3 decimal places. So this question is more or less similar to the previous questions that we've done. So we're going to follow the same procedure, only that in this question we are calculating the area. We're getting the error in calculating the area. So again, the things that we require from this question is the maximum area. Then we need the minimum area, and we also need the actual area. And with all these, we also need to know how to get the percentage error, which we've just seen in the previous question. Absolute error over the actual. So in this question, you're dealing with the area, so this will be actual area multiplied by 100. So let's go straight to the first thing, the maximum area. But before we go to the maximum area, we need to look at the measurements that you're given, 8.2 and 6.3. The least unit of measurement is 0.1. Therefore, to obtain the absolute error in each of those measurements, we divide by 2, so 0.05. This is important in giving us the limit which will be used to calculate the maximum and the minimum area. Now, using this figure, like in the first unit, this 8.2 centimeters will lie between that. Then the other measurement, 6.3, will lie within these limits, plus or minus 0.05. So to obtain the maximum area, we shall take the upper limits. The upper limits are obtained after adding 0.05 to each of these measurements. So 8.2 plus 0.05. And then it is important to notice that we are dealing with this one is a triangle which has a height, a perpendicular height. So the area of the triangle will be given by a half times the base, the base, which is 8.2, times the height. The base, the upper limit, will be 8.25 times the upper limit of the height, which is 6.35. So when you work out these using the calculator, this is what you're supposed to obtain. Supposed to obtain 26.19375. Now let's go to the minimum area. The minimum area will be obtained by taking the lower limits. Now what you've done for the maximum, we have added 0.05 to get the maximum area. To get the minimum area, we shall now subtract 0.05. This is what you're going to get. So area is equals to a half multiplied by, so take 8.2, subtract 0.05, and this gives 8.15 multiplied by 6.3, subtract 0.05, you get 6.25. So working out this using the calculator, you get 25.46875. That is what you get. The other thing that we need is the actual area. The actual area is the one that is you obtain by using the raw data without having to add this error 0.05. So it will be a half times the base. The actual base is 8.2 and the height is 6.3. So these are how we obtain the actual area, and this gives 25.83. Having these three, now we have the maximum area, we have the minimum area, and the actual area. Now we can get the absolute error in area is obtained by a half the maximum area minus the minimum area, and these will be given by, we have obtained all these figures, you have them. So I have maximum area, we have obtained that one as 26.19375 minus minimum is 25.46875. So working out these using calculator, get 0.3625. Now, having obtained the absolute error, we can get the percentage error. Therefore, will be obtained by the absolute error, which is 0.3625, everything divided by the actual area, which is here, the actual area, which is 25.83. So 25.83 multiplied by 100%. So working out these using the calculator, this is what you get. You get 1.403. Now the answer, you're required to give the answer correct to 3 decimal places, and therefore that is how you're supposed to do it. So that is how you're supposed to solve that question. Question number 4. The length of a rectangle is 8.3 centimeters and its width is 5.45 centimeter. Calculate A, the relative error in the area of the triangle, B, the percentage error in the area of this rectangle. So this is a spelling. So rectangle. So the first thing we're going to do is to go to the first part. We are required to get the relative error in the area of the triangle. Now to do that, we need to get the absolute error in each length. So solution. So absolute error in length, be given by the length, the least unit of measurement for the length is 0.1. So divide by 2, this would be 0.05. Then the absolute error in the width, the least unit of measurement for the width is 0.01. So divide this one by 2, you get 0.005. That is the first thing supposed to do. So relative error in the area will be obtained by adding the relative error in each of the units or the measurements that you're given there. This is what I mean. So for part A, in obtaining the relative error, we obtain this by adding the relative error in each of the measurements that you're given. For example, the relative error in the length will be given by, and before we proceed, relative error is obtained by getting the absolute error over the actual measurement. That is how we get it. So in this part, we're going to take a relative error in the length, which is 0.05 divided by 8.3. Then we add relative error in the width, which is 0.005 divided by 5.45. So these, the whole of these will give the relative error in the area of this rectangle. So working out this using the calculator, 0.05 divided by 8.3, we get 0.0062400963, then plus 0.05 divided by 5.45, we get 0.0002174 19. So those are the figures that you get. Then adding the two, you add the two. This is what you're supposed to get. You get 0.0694152,758. So that is the solution for part A, the relative error in the area. Then the second question, sorry for this zooming. The second question, let me zoom this one for proper view. That's okay. It's okay. The second question, the percentage error in the area, the percentage error. So part B, so you're supposed to get the percentage error. Percentage error is obtained by, this is just another formula. You can give it as the absolute error over the actual measurement. This is the actual area multiplied by 100. And you notice that this part represents the relative error. So you can either use this or this. This is the same thing, because absolute error over the actual area in this question is the same as the relative error, since we have just indicated here before that relative error is given by absolute over the actual measurement. So it's still the same thing. So what we need to do here is to obtain the relative error that we've got, which is 0.00694. We can cut it up to 4 significant figures. We round it off, then you multiply this by 100, and these will give 0.6942 as the percentage. This is the percentage error. So that is how you're supposed to work out that question. Question number 5. Find the percentage error in the area of a parallelogram whose base is 23.2 centimeters and height is 11.5 centimeters. So this question is almost similar with the ones that we've done previously in our other questions. So we're supposed to find the percentage error in the area of a parallelogram. To obtain the area of a parallelogram, this is obtained by base times the height. That is the base times perpendicular height. So we need the things that we have just observed in the other question. So one, we need to obtain the maximum area, we need the minimum area, and we need the actual area. The least unit of measurement is the same. The least unit of measurement is 0.1. So to get the absolute error in each of the measurements, we divide this by 2, we get 0.05. So each of the measurements will lie within this limit, 0.05. So we begin with the maximum area. For maximum area, as usual, we shall add 0.05 to each of these measurements. So the first one is 23.2. So we add 0.05, we get 23.25. Multiply by, the other one is 11.5, we add, so 11.55. So we obtain this by adding plus 0.05 to each of these units. So that is how we do it. So 23, I can write it here for clarity. 23.2 So 23.2 plus or minus 0.05. Then the other measurement is 11.5. That is okay. So multiply these using the calculator. 23.25 multiplied by 11.55, get 268.5375. So we get the minimum area. So minimum area, we subtract 0.05 from each of these measurements. 23.15 multiplied by 11.45. So we multiply that using the calculator, we get 265.0675. So the next thing that you need to get is the actual. You can get the actual area. So actual area. The actual area, we are going to use the raw figures without adding the limit. These are absolute error. So 23.2 multiplied by 11.5. So when you multiply that, this is what you get, 266.8. 266.8. Now, after getting these, as usual, so absolute error in the area will be given by half the maximum area minus the minimum area, and these we obtain most of these. So half maximum is 268.5375 minus 265.0625. These are the figures that are here. Working out these very fast using the calculator. You get it using the calculator. This gives 1 point. This correct to 4 significant figures. Now we obtain the absolute error. So therefore, the percentage error will be given by absolute error divided by the actual error, which is the actual area, which is 266.8 multiplied by 100. So this gives working out this using calculator, it gives 0.6503%, and that is how you're supposed to work out that question.